In this lecture, I want you to see that you can avoid the hard work we did to set up iterators by using row pointers as iterators. And all you need to do is just return the pointers with your begin and end methods. And that's what we're doing here. We're going to comment out all the iterator work we did before, and we're going to provide a begin and end method, which is going to return just the pointers from our m items dynamic array. The end iterator is just going to be the m items pointer plus size. This is going to take us past one element in our collection, and we're going to provide C begin and C end, which are going to be returning constant iterators. But notice that we are requiring that they return const, so this is what we can do here. If we want, we can even provide begin and end overloads that return const data to be used with const containers, as we saw in the last lecture. Once you have this in place, don't be surprised, this is going to work really well. So we can use this with our box container object. We set it up here. Once we have the collection, we can really do all kinds of crazy things. For example, we can use a range-based for loop. This is going to work. We can sort our collection. We can use views. We can do all kinds of crazy things. And this is working because a pointer is one of the powerful iterators in C++. It really is comparable to a random access iterator because it can do the same things we did in our random access iterator. So all these algorithms are going to work with our pointers that we are returning as iterators in our begin and end methods. One thing you need to be careful about is that for this to work with const, we also need to provide const overloads. So we are going to do that in a minute, and you're going to see that this is going to work here. This is really cool. We can even go through our print function, which takes a box container which is const as a parameter, and this is going to work really well. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is row pointers as iterators. We're going to grab the code from the last lecture because it's going to give us everything we need. And we're going to paste this in our current project. We're going to crack this open in Visual Studio Code by dragging and dropping here. We are going to have the main file, and I think we can clean it up a little bit. So let's take out everything we had here. We're going to leave in VI, and I think this is going to work just fine. Now, what we want to do is go in our box container and comment out everything we did in terms of iterators. We're going to comment out our begin and end methods. So we're going to come all the way to this place, 271, and we're going to comment out. And we're going to go all the way to the top where we did our iterator class. We are also going to comment that out. So we are not going to do anything fancy here. What we want is to return the pointer to our underlying containers as iterators. So we're going to grab the pointer to the first element. That's going to be our begin iterator. And we're going to take a pointer to past the last element, and that's going to be our end iterator. So the syntax to do that is really simple. Let's go all the way to the top. That's where we're going to do this in our public scope here. So I am just going to put in the code and explain it. Let's make sure we align this properly. So we have a begin method, which is going to return a pointer to the first element. We have an end method, which is going to return a pointer past the last element in our collection, and this is going to be our end iterator. Notice that we have const overloads. We have a begin and end method, which are const, which are not going to be modifying our collection, but they are going to be returning const iterators that we can't go through to modify our underlying data structure. We also have cBegin and cEnd, which are just going to return const iterators. This is going to work really well. Again, some of you must be asking, why is this working? This is working because a pointer is really like an iterator. And to break it to you, the iterator concepts that we have in C++ were designed in hope that they could mimic the behavior we have with pointers, things like pointer arithmetic and all kinds of crazy things. And this is going to work really well. Let's go back to the main CPP file and show you that this is actually going to work with all kinds of crazy things. The first thing I'm going to do is create a copy just like we did in the last lecture, and I am going to show you that this is going to work. Let's pass this through the compiler. We can use GCC, but any other compiler is also going to work. You see the build is good. We can bring up a terminal window. Let's do that. And if we clear and run Rooster, we're going to see that we are printing our data. This is no problem. Again, this is working on our const container because we have a const overload that is going to make this work. This is really important to understand here. We can also print through our print function. So we're going to be printing our copy here. Let's pass this through the compiler. We're going to use GCC. The build is going to be good, and if we clear and run Rooster, we're going to see our copy, which is going to contain exactly the same data as we have in VI here. So this is working pretty well. Okay, we can also try to sort, and I'm going to show you something that many of you might try to do. For example, we can try to say std ranges sort and sort our copy, but this is not going to work because the copy is const. You can see that right here. So it is a constant container, and sorting it out would be attempting to modify it. So this is not going to work because you can't really modify it. If we're trying to do that, we're going to get a bunch of compiler errors, but that's going to be the reason here. So we have our compiler errors. To fix this, we need to make sure what we sort is not a constant collection, and we can use VI as an example here. So we're going to sort this. And this is going to work because a pointer is really like a random access iterator. So the sorting algorithm here is going to work without a problem. Let's pass this through the compiler. Let's use Clang and see if this works out with Clang. You're going to see that the build is going to be good. Let's wait for it. Okay, the build is good. We can clear and run Rooster. We're going to see that VI is going to be sorted now after our sorting algorithm. But this is not all. This can also work with range adapters and views that we saw in a few previous chapters. So for example, if we set up a view that is only going to take 3 elements from our collection, we're going to see that if we print that, we're going to only see 3 elements printed out. Let's pass this through the compiler. We're going to use GCC because it is my favorite here. The build is going to be good. We can clear and run Rooster, and you're going to see that if we have a view taking only 3 elements, we're going to take 1, 2, 3, and this is really cool. This is all I had to share in this lecture, showing you that you can set up iterators by just returning pointers to your underlying collection, and this is going to work really well. We are going to stop here in this lecture. In the next one, I am going to show you that you can actually wrap around iterators returned by other collections and set up your own collection if you need to do that kind of thing. Go ahead and finish up here and meet me there.